See, today we'll talk about a wind problem. It is pretty much similar to a river problem. So we know that. We already discussed about this thing, earlier. Mhm. So see, velocity of some object O with respect to wind can be written as velocity of object minus velocity of wind. So simply we can say that velocity of object with respect to ground is can be written as velocity of object with respect to wind plus velocity of wind vector A. So this is it, nothing else. There is nothing extra theoretical in this. So we'll start with a good question. See, question says that suppose there are four towns like this. There are four towns. Town A, town B, town C, town D. Situated like a square. This is a square whose length is L, 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 and L. Right. Now, we are given velocity of air, or suppose there are four towns. Aeroplane is flying from town A to town B, town B to town C to town D, and town D to town A. Aeroplane will fly, and it's given um, velocity of air with respect to wind is v. Velocity of air with respect to wind given as v, and wind is blowing like this. Wind is blowing like this, parallel to town AB, parallel to the line joining town AB and perpendicular to the line joining BC and like that. So this is perpendicular. This is air. Air is blowing in this direction. And velocity of wind is given as speed of wind is given as u.
So can you repeat the question again? I missed it.
Yeah, there are four towns A, B, C, D situated uh, they are like your vertices of a square, and the wind is blowing parallel to the line joining AB and perpendicular to the line joining BC. This is also perpendicular. And suppose aeroplane flies from town A to town B, B to C, C to D, D to A. Then how much time it will take? Suppose an aeroplane started from here, town A, it will go to town B, C, D, and come back to A. So how much time it will take? Find time taken by aeroplane to fly from A to B to C to D and come back to A. Note it down, then I'll solve it.
सर हम इसको s इज इक्वल्स टू ut प्लस हाफ 80 स्क्वायर से कर सकते हैं ना डिस्प्लेसमेंट
हाँ,
जीरो
सेम कॉन्सेप्ट लगाएंगे. There is no formula here. We'll just apply some logic and it will be done. First, you note down the question, then I'll solve. You'll understand the concept. Noted, everyone? China? Archit, noted?
यस सर
Now see. Suppose let's find first time taken by aeroplane to travel AB. This line. You know that air is also blowing parallel to AB. So in the same direction, right? So you can feel that aeroplane will start with some velocity. With some velocity. If aeroplane, suppose start in this direction, velocity of aeroplane, right? and wind is also blowing in the same direction. So the net velocity of this aeroplane will be velocity of aeroplane with respect to wind can be given as velocity of aeroplane minus velocity of wind. So velocity of wind aeroplane can be given as velocity of aeroplane with respect to wind plus velocity of wind.
So, but this is not relative velocity. So, don't you have to add it because the wind is propelling it further? So,
See now, velocity of aeroplane with respect to wind is given, relative velocity is given. So we have to use this. Direct velocity of aeroplane is not given.
so if an object is moving in wind and it's moving in the same direction, wouldn't its speed add to the wind speed?
Yes, yes. So added na, see na. It's been added. They are
Oh,
both in the same direction. They are added.
okay.
So time taken by aeroplane from A to B is L plus L upon V plus U. Right? Now, time taken by aeroplane from B to C. B to C. Now you see, if aeroplane starts like this along line BC, then we know that this is the velocity of aeroplane, and in towards right, this is the velocity of air. So air will drag it to the right. So aeroplane will come like this over, right? So aeroplane cannot reach to B point, right? So because this is the velocity of air and this is the velocity of aeroplane, and net velocity will be in this direction. So aeroplane can never come to this point. So for that, aeroplane has to start like this, at some angle like this, so that this is the velocity of aeroplane with respect to air. So that if you add the velocity of air, the vector sum of this vector would be net velocity vector along this line BC. Understood? So at some angle it will start. Now, if you find the velocity of the net velocity of this aeroplane, then you can find this. This is VAW, this is VA. So this would be under root VAW square minus U square. So time taken by this will be V square L upon V square minus U square. Understood? If you see time taken by aeroplane to come from C to D, so in this case, wind is blowing in this direction, U, and aeroplane will have to start in this direction. So the net velocity will be V minus U because they both are in opposite direction. So time taken will be L upon V minus U, and time taken for D to A will be for D because air, uh, air is blowing in this direction, right, in the right direction. So if aeroplane suppose starts in this direction, so air will wind will drag the aeroplane further towards the right only. So net velocity will be somewhere like this. So it can never reach to A. So for this, so aeroplane has to start at some angle like this. So that if you this is the velocity of aeroplane with respect to air, and then if you add velocity of air, so the net velocity can be along this line, and aeroplane can go from D to A. So this is velocity of uh, air. So this is your V and this is your U. So again, this would be, if you apply Pythagoras theorem, so this is V square minus U square. So L upon under root V square minus U square. So total time would be L upon V plus U plus L upon V minus U plus twice of L upon under root V square minus U square. So this much time it will take. है ना? Understood?
Then, sir.
Now I'll give you one question for you guys. Question is, suppose this is town A and this is town B. Suppose aeroplane wants to come from town A to town B. And here wind is blowing in this direction, at certain angle, with the line joining town A and town B. This angle is given. And velocity of wind is given as u, and velocity of aeroplane with respect to wind is also given as v. So you have to find time taken by aeroplane to travel from town A to town B. Solve it.
So we don't have distance, so do we just assume maybe?
A, B are 2 points.
No, distance, sir. We
Oh,
just take
distance given is L between A and B.
So, one way is just L divided by root of u square minus v square. But then because they gave us alpha, so then you can use sine theta or cos theta.
You can think like, suppose, see, wind is blowing in this direction, right? At some angle, alpha. Suppose your aeroplane starts like this, along line AB only. So wind will just drag it to that side, right? So aeroplane will go somewhere here. It can't come to B. Okay. If suppose aeroplane starts at some angle like this, so aeroplane will further push it to some other, like,
So the plane has to start alpha degrees below.
yeah, yes. So if plane wants to come from A to B, plane has to start something like that. This, so that if air will push it to and resultant resultant velocity can be along the line AB. Then aeroplane can come from A to B, right? Archit.
Yes, sir.
Suppose aeroplane starts at some angle theta with some velocity. Suppose velocity of aeroplane is VA. So it will have two component, VA cos theta, and then this is VA sin theta. And this wind has two component again. See this and this. So this is U cos alpha and U sin alpha. Now see, there are two kind of velocity. See, let me draw this again. This is suppose this is the horizontal component of aeroplane, and this is vertical component of aeroplane, and this is vertical component of wind and horizontal component of wind. Right? Now see, if you see, if this U see here, if this U sin alpha means vertical component of wind will be more than this. So if this is bigger than this, so resultant velocity will be towards up. So there will be one velocity here like this, resultant, and this is the horizontal component. So resultant velocity will again be like this. So aeroplane will go at some angle with this line. So aeroplane cannot come to B. But in case suppose this component is vertical component of aeroplane is more than vertical component of wind, then resultant velocity will be downward. So this will be the velocity and this is the horizontal velocity. So resultant velocity will come like this. So again aeroplane we cannot come to point P. It will go somewhere else. For that, this component must be equal to this component. So that this both of this will nullify each other and the resultant velocity of the aeroplane will be this only. So in that case, aeroplane can directly come from A to B. Understood? So we have got this relation. This equal to this. U sin alpha equal to VA sin theta. And so from here we can get see okay, so theta is unknown and VA. So VA we can write velocity of aeroplane with respect to wind. This is equal to velocity of A minus velocity of wind. This is vector quantity. So velocity of A is velocity of wind, aeroplane with respect to wind plus velocity of wind. So we have to find magnitude of this, right? So you can also find here velocity of air with respect to wind. So this is given. This is where see. This is velocity of air with respect to wind is given a v. But that is speed actually, right? Speed. And this u is given. So from here you can find uh, so the net resultant velocity, see, net resultant velocity of this along the horizontal direction will be this VA cos theta and plus U cos alpha. Understood? And this VA, this should be the this. This was the velocity of air with aeroplane with respect to wind. That was V. So this is your V. And this is also this. So U sine alpha equal to V sine theta. Because aeroplane has to start at this angle with this velocity that is given here with respect to wind. So we can find this here. So this is your net velocity along X, and velocity of aeroplane with respect to wind is velocity of aeroplane minus velocity of wind. So velocity of aeroplane will be with respect to ground will be velocity of aeroplane with respect to wind plus velocity of wind. So if I take x component of this, if you assume this as x and this as y, so x component will be this plus this. Let's write this VAW. 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 So this is V cos theta plus U cos alpha. And vertical component will be nullified. So time taken will be L upon this component, that is V cos theta plus U cos alpha. You just have to replace this cos theta from here, from this relation. So L upon V under root 1 minus sin square theta, that is U squared sin square alpha upon V squared plus U cos alpha. That's it. So L upon this V and this V will cancel, under root V squared minus U squared sin square alpha plus U cos alpha. Understood?
So I didn't completely understand how you got that equation VAX equals V squared. So can you explain it again, sir?
Okay. See, there are two terms over here, A and B. Aeroplane wants to come from A to B. Distance is L. Wind is blowing in this direction. Velocity of wind is given as U at some angle alpha. Now you have to find time taken by aeroplane to travel from town A to town B. See, wind is blowing in this direction. This part you must have understood, like, aeroplane has to start at some angle in this direction, so that at some angle theta, so that when aeroplane will, when wind will drag it to in this direction, the resultant velocity of this aeroplane can be along the line AB, and aeroplane can come to B, right? So let's say aeroplane has started at this angle with some velocity V. So this is the velocity of aeroplane with respect to wind, that is given as V. Because with respect to air, it has to start at this angle, right? And the resultant velocity of uh, aeroplane can be along the line AB. See, so there will be two components of this velocity. That is V cos theta, and this is V sin theta. And there will be two components of wind, U cos alpha and U sin alpha. I told you that this vertical velocity of aeroplane and vertical velocity of wind must cancel each other. Otherwise, there will be some net force, maybe either along up or along down. Right? So these two will nullify each other. V sin theta equal to sin A. Did you understand?
Yes, sir.
Theta is unknown for us, so we can just replace this. And the net velocity will be along AB, this plus this. So time taken will be distance upon total velocity. So cos theta you have to replace, that is 1 minus sin square theta. For sin theta you have to replace this U square sin square alpha upon V square plus U cos alpha. Take LCM. This is under root V squared minus U squared sin square alpha. And this V and this V will cancel, and this is U cos alpha. Let me know if you understood now or not.
Yes, sir, I understood.
अर्चित समझ में आ गया?
ये सर आ गया सर बट अगर क्वेश्चन मतलब आंसर में ये ऐसा ऑप्शन हो कि v cos थीटा तो हमें फिर उसको मतलब sin थीटा की टर्म्स में फिर चेंज नहीं करना है ना
Theta unknown है ना, theta is not given in question. So unknown you can assume as per your choice, but you have to in the end, like in the answer, you have to replace that unknown.
तो
Understood.
Noted?
2 minutes. Done.
Now, rain problem. See, suppose now we are standing somewhere and it's raining, right? So you can observe the actual direction and actual speed of rain. But suppose you are also traveling with some velocity. In that case, direction of rain will also change and its speed will also change, right? When you run fast, right? Then you feel that you are kind of rain is coming faster to you, right? So velocity of rain with respect to man can be written as velocity of rain minus velocity of man. Or you can also write velocity of rain plus minus velocity of man. So to find the relative velocity of rain with respect to man, you just have to add the reverse of velocity of man to the velocity of rain, right? Okay. Suppose, let me take one simple example. This is the ground. One man is running with some velocity. Let's say this is velocity of man is with respect to ground, that is 6 meter per second. Considering this is x and this is y. And rain is falling vertically. Rain is falling vertically with 8 meter per second. This is the velocity of rain with respect to ground. This is given as. But this man will not see rain falling vertically. This man will see rain coming at some angle. So you have to find the velocity of rain with respect to man, first thing. Also, find direction in which man should hold the umbrella. First question and second question. See, man is also moving. So now what we'll do, we'll analyze the situation uh, with respect to man. So what we'll do, we'll bring this man to rest. So we'll bring this man to rest. So what will happen? We have to add the velocity of man to the velocity of rain in reverse direction because the man is moving towards the right. So you just have to do reverse of this velocity and add it here. So net velocity will be in this direction, right? So this is 6 and this is 8. So resultant will be 10 under root 6 square plus 8 square. And this angle will be, you have to find, suppose this is angle theta. So tan theta is, this is 6. So this is 6. So 6 upon 8. 6 upon 8, that is 3 by 4. So theta is 37 degree. So this man So the velocity of rain with respect to man will be magnitude is speed of rain is 10, and at man will observe this rain is falling at 37 degree with the vertical. So man has to hold his umbrella like this. At some, this is 37, this is 90, so this will be 53 degree. At 53 degree, man will have to hold the umbrella. Then rain is falling like this, man is going right. So reverse the direction of man velocity. This is V. If you do vector addition, this plus this would be what? This, na? That is velocity of rain with respect to man.
Got it, sir.
So analyze the situation in the frame of man.
Done, sir.
Suppose next question. Say the graph. This man is moving with some velocity towards left. Suppose this is the velocity of man, and he observes that rain is falling at some angle, suppose 37 degree with the vertical. This is the velocity of rain with respect to man. No, rain is actually falling at 37 degree with the vertical with some speed that is 20 meter per second. Man is also moving, or man will move, and rain is falling at 37 degree with vertical. You have to find velocity of man such that he will observe rain falling vertically. So at what speed man has to run so that man will experience rain is falling vertically.
So
So
is the
now
man moving left direction or right?
you can think, suppose if man is moving towards the right. So now
सर आप
suppose man is
लैग हो
moving
गई
towards the right. Suppose man is moving towards right. Now we'll have to observe the situation in the frame of man. So man will come to rest, and you have to reverse the velocity of man and add it here. So if you add somewhere here, so you can okay. So okay, suppose this is the velocity of man. So you just reverse it and add it Vm. Now man has to observe the rain will fall vertically. So this is the velocity of rain with respect to man, right? So see, this rain has two components. This rain will have two components. One component this and one component this. So this is 20 sine 37 and this is 20 cos 37. Now you can see that m- this velocity is in this direction. This and this will combine and will give you net velocity. So now finally you will have net velocity towards this direction and vertically down as well. So net velocity will be somewhere like this. So it won't be seen as coming vertical. So man cannot go left, cannot go right. So man has to go left so that it can see man has to go left because see this rain has two components like this is the actual angle at which the rain is falling with some velocity 20. It will have two components. this and this. This is 20 sine 37, 20 cos 37. Now, man has to travel towards left, so that if you observe the situation with respect to man, you have to reverse its velocity and add it here, so that this and this will nullify, and this man will observe only one component, that is vertical. So this must be equal to this. So 20 sine 37 must be equal to velocity of man. So man has to run with 12 meter per second towards left. Understood?
सर पिछले क्वेश्चन में हमें अम्ब्रेला 53 डिग्री पे वो होल्ड करना
हाँ. And if you have to find, suppose, the velocity of rain falling down vertically with respect to man, so this will be the velocity of rain with respect to man. That is 20 into 4 by 5. So man will observe rain is falling down vertically with the speed 60 meter per second, but the actual speed of the rain was 20. Now, next question. See, actually rain is falling at some angle 37 degree. So this is the velocity of rain actual speed, that is 20 meter per second. So rain is falling at angle 37 with the vertical, right? Now you have to find the velocity of man, and also you have to decide the direction. What would be the velocity of man, so that man will observe rain falling at 37 degree with the vertical. Find velocity of man such that he observes the rain to be falling at an angle 37 degree with vertical. See, I'll solve it, don't worry. See, case 1. Rain is falling at 37 degree, and you have to find the velocity of man, so that man will observe that rain is falling at 37 degree with the vertical. So one case will be what? Man will be at rest.
Yeah.
So man will observe the rain falling at the same angle 37?
One more is if he's moving in the same velocity of the rain as the rain.
No, see. Another case would be case number 2. Man will acquire some velocity, so that he will experience the rain is falling like this, 37 degree angle with the vertical. Understood? Now you think, try, give it try.
So 20. Oh, yes. So 24 meter per second.
Correct. Mhm.
Sir, I didn't get it.
Sorry?
Sir, I didn't get it.
Okay. See, man has to observe that rain will fall at this. So this is the velocity of rain respect to man at 37 days. Now, man will have to run towards right. Why so? So that, suppose this is the net velocity of rain with respect to man. So that, if man will run towards right, how do you find? See, velocity of rain with respect to man is velocity of rain minus velocity of man. It can also be written as velocity of rain plus minus of velocity of man. So if man is going right, you can add simply like this, right? That is how you can find, you can observe in the frame of man. So man will come at rest and you can add the velocity of man in opposite direction. That's how we find relative velocity. Now, is there any velocity? So this man will observe that rain is falling at 37 degrees. So speed of rain will be 20 meter per second only. At the same speed, that is missing in the question. I did not mention that. So this will also be 20 ohm. So you have to find this Vm. That is minus of Vm. So this is 20. So this would be 20. See, this is your x and this is your y. So x upon 20 will be sine 37 degree. So x will be 20 into sine 37 degree. That is 12. So this is 12 and this is also 12 because this is 20, this is 37. 12. So this would be 12 plus 12, 24. So the speed of man will be 24 towards the left, towards the right. Understood, Pranay? Uh, Archit?
Yes. Done, sir.
Let me get one good example of and Giving you one question, you have to solve that. Try this. To a person, no, English is incorrect. A person traveling due east, something like that, or maybe like this. You can check. What do you think? Would you be able to solve this?
No, sir.
Shaina?
I don't think so, sir.
Okay, let me try.
But sir,
To a person,
looking at the answer, it looks like they're finding the angle between the resultant and one of the vectors. But
okay. To a person traveling due east. See, east, west, north, south. To a person traveling due east with velocity u, the wind appears to blow from an angle alpha north of east. North of east means from east to north. If this person will travel in east direction, in this direction, suppose with u velocity, then he will observe that from east to, so the wind is coming like this. Hmm. Like this. Wind is blowing in this direction. From east to north, that is angle. This is the velocity of wind. He will observe it. When he starts traveling due north, suppose this, when he starts traveling due north with a speed 2u, or velocity 2u, the wind appears to blow from an angle beta from north of east. Again, this angle. This is angle beta from north of east. So from east to north. And the true direction of wind. Okay, do one thing. Suppose true direction of wind is theta. Let's assume that true true direction of wind is theta. I don't know. Theta is south of west. At this angle, okay. Let it be. I'll find later. See, velocity of wind with respect to man is velocity of wind minus velocity of man. So from here you can find velocity of wind is velocity of wind respect to man plus velocity of man. So with respect to man, velocity of wind is something, suppose v, that is given as v cos alpha I plus v sin alpha j, this this and plus u I. So from here you can see v cos alpha plus u I plus v sin alpha g. So this is the velocity of wind with respect to ground. In this situation, if you see, again we'll apply the same logic. There is no formula and nothing. So velocity of wind with respect to man is velocity of wind minus velocity of man. So velocity of wind again we can find here velocity of wind with respect to man plus velocity of man. In this direction, velocity of wind will be how much? So speed will be same. Let's keep speed same. Wait, wait. But no, speed will be speed of the wind will be different. Here you have to assume that this is v dash because velocity of man will be different. Then man will experience different velocity of wind. So this is v dash cos beta I plus v dash sin beta j and plus 2u j. So from here, V dash cos beta I plus V dash sin beta plus 2u j. From here we can find. Right. Now, this V and V dash is not known. Right. And this VW is the actual velocity of wind. So from here, we can, and nothing given about the speed of wind. So from here, we can simply observe the direction of wind only. Hmm. Okay. In this case, we can see that man is moving towards east, and with respect to man, this velocity of wind is at this angle theta. So if I consider in the frame of man, you have to just reverse the velocity of man, and you have to add it to this. Hmm. Here we have to find one thing because speed of wind we have to find. Na. We do one thing. So this thing we have done, right? Now you can see this is the actual velocity of wind, and this is also the actual velocity of wind, right? So both has to be equal from both the equation. This is case one, suppose, and this is case two. In case one, we have got the actual velocity of wind, and from case two also we got the actual velocity of wind. Understood?
But sir, they are just velocities that are being observed from that place.
Sorry?
Aren't they just the velocities of wind that is being observed?
No, 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 no. See, velocity of wind with respect to man. This is the velocity of wind
Oh,
observed by man. This is
okay.
the actual velocity. This is the actual velocity of man, right?
Yeah,
So
understood.
from both the cases, like, no, we get the same thing. So this and this must be same. So I component of this must be equal to I component of this, and j component of this must be equal to j component of this. When two vectors are equal, right? Understood, everyone? Archit and Shaina.
Yes, sir.
So from here, just compare the I component, that is V cos alpha plus U equal to this V dash cos beta, and this V sin alpha must be equal to V dash sin beta plus 2E. Now,
So you
because
divide
V and V dash is not known, na?
them.
But that won't get cancelled. Na?
So V
Then any speed that is given, U is given. Okay, fine. No,
so we can write V in terms of U.
mm. Let's do one thing. Let's replace V dash from here. V dash is V cos alpha plus U upon cos beta. I'll just replace V dash from here. from here, right? Put V dash here. So this is V sin alpha and V dash is V cos alpha plus U upon cos beta into sin beta plus 2U. Correct? Then cross multiply this V sin alpha into cos beta.
सर बट क्रॉस मल्टीप्लाई से हमारा 10 और cot में नहीं आ पाएगा ना.
Wait. It's not that easy. Let me solve it. Plus 2U cos beta. Because no, we do not have V na. We have U. V is not no. So we have to do something. What we can do is bring terms having V together and keep terms having U together. So bring this to left. So V will be common and this is sin A cos B minus cos A sin B. So it is like sin of alpha minus beta equal to take U out. This is sin beta plus 2 cos beta. So from here we can get V upon U as sin beta plus 2 cos beta upon sin alpha minus beta. What else can be done? You have to find at what angle true direction of wind, right? And you have this V by U. So with the help of this, we can do one thing. So this is the actual velocity of wind, right? So suppose this is your V cos alpha plus U along I, and this is V sin alpha. This is the actual velocity of wind. If you want to find this angle, so tan theta would be how much? Tan theta would be V sin alpha upon V cos alpha plus U. This is what you want to find, right? Right.
Yes.
And you have V by U over here. So just divide this by U. So V by U sin alpha. This is V by U cos alpha plus 1. Put the value of V by U here. Sin beta plus 2 cos beta into sin alpha upon अरे बाप रे sin alpha minus beta. We are not going to solve this upon sin beta plus 2 cos beta upon sin alpha minus beta into cos alpha plus 1. If you solve this, you will get the same expression. See, there is no variable here, right?
So how did you get V by U, sir? V by
From
U.
here, after comparing, so see, from this equation we got V dash, put in this equation. You got
No,
this.
not that, sir. Uh, tan theta equals V sin alpha by V
See,
cos
na,
alpha.
if there are two vectors, suppose, see,
So the next step.
this one, na,
No, the step after that.
this one, na,
Yeah.
just took u common from here. So this is v by u cos alpha plus 1 and this u that you took common, it will go to numerator and it will again make this term, v by u.
So how can it?
Understood?
How does it go to the numerator?
See na, from here, see, this is v sin alpha. Take u out. So u will come out. So this will become v by u cos alpha plus 1. If you multiply, you get the same thing. And this u will now go to this. So v by u sin alpha and this will be here. Understood?
Oh, okay.
No, you don't solve it because this is too lengthy. One more question I have given. I'll give. First note it down. Don't solve it.
Done, sir.
Hmm. Try this one.
सर कैसे करेंगे इसको?
China, any idea?
So I'm still thinking, sir, but then it's similar to the.
See, let me tell. A vertical wind screen of a car is made up of two parts, as shown in the figure. Where the upper one A, that is 25 centimeter vertically long and covers the 5 centimeter of the lower piece. So when it will come over here, it will cover this. So this distance is 20 centimeter from here to here. The upper one is hinged at the top so that it can be opened outward, inclining to the vertical. The car is running on a horizontal road at 60 km per hour in the rain, which is falling vertically at 20 km per hour. So this is the rain. So rain is falling vertically and car is moving to, horizontally, right? So you can see that resultant should be like this. No. So how do you find? So if you sit in the frame of car, this is car and this is rain. So if you sit in the frame of car, what will you observe? So you just have to reverse the velocity of car and add it to rain. So that would be the direction of the rain with respect to car. So that's how rain will fall. This is 20 and this is 60 km per hour. Did you understand that? Rain is falling vertically. You are going towards the right, like this, like this. So rain will fall towards you like this. So it means like, you just have to reverse your velocity and add it vectorially to the velocity of rain so that you can get the net resultant velocity of uh, rain, right? Now find the maximum. Got disconnected Wi-Fi. Wi-Fi lost actually. So I just connected over hotspot.
So you stopped at resultant.
Yes, yes, I'm telling you. Now you can see that. So how? So suppose if you sit in the frame of car, so you have to bring that car into rest. So how do you do that? You just have to reverse the velocity of car and add it to rain. So you'll see that rain is falling like this with respect to car at some angle, right? At some angle. Now, question says that find the maximum angle through which the upper part A can be opened. So for what would be the maximum value of theta? So that such that raindrops do not enter the car.
So, sir, like the umbrella question from below.
Yes. So this is C. Yes, yes, right there. Like that only. This is 20 and this is 5. Suppose you have opened this till here. And now, if you think that, so what could be the maximum angle at which rain can fall? Like this one. Like this one. If, like, so this is the angle made by uh, rain with vertical. If this is bigger than this angle, then rain will be like this, and it will enter. See, this is 5 centimeter part that is covered, right? And this 20 centimeter part will be open. So if you open more this part, so rain will have some space to enter into the car. Understood? So, but rain do not should not enter the car. So for that, this should be the diagram. This should be the diagram. This is 20, this is 5. For suppose this is angle theta, and this is the maximum value, right? And you have to find that this angle theta. How will you find that? This is x and this is y. So this is the resultant velocity will be minus 60 I minus 20 j. This is the velocity of rain with respect to car. Minus 60 I minus 20 j. Right. So what angle it should be? This angle should be, you can find alpha from here. Now, just drop a perpendicular here. Drop a perpendicular over. Now, how will you find this? This is alpha. So this will be alpha. This is 90. This should be 90 minus alpha. And this should be 90 minus theta. So the complete angle would be 180 minus alpha minus theta. Now you know that this
We don't
length
need
is,
that angle, sir.
sorry,
We don't need that angle, sir.
okay, let me solve. This is 20 and this length is 25, you know that. This length is 25, this length is 20. So if you see in this triangle A, B and C, you know sine rule. You know sine rule. Sine rule says that sine upon sine of opposite angle equal to B upon sine B equal to C upon sine C. In this triangle A, B, C. This is A, B, C. So A upon sine A equal to B upon B upon sine B equal to C upon sine C. Like that. So in this triangle, if you apply this concept, you will see that 20 upon sine of opposite angle. So angle opposite to this side 20 is this angle. So sine of 180 minus alpha minus theta equal to 25 upon this angle. That is sine alpha. And from here we can find tan alpha. How? This is 60, this is 20. So like this is 60, this is 20 vectorially, this is 60. So this angle alpha is tan alpha equal to 60 upon 20. 60 upon 20, that is 3. Correct. Now solve this, you'll get the answer. You should get the answer. I don't 5
So
sine
what is
180 minus theta.
so what is alpha?
Alpha is the angle made by the
No,
ray
so what's
which
the value?
alpha will get from here tan alpha equal to 3.
Okay.
So see here, this is 5 upon sine alpha. Just cross multiply this 4 sine alpha equal to 5 sine alpha plus theta. Sine A plus B. That is sine A cos B plus cos A sine B. And this is 4 sine alpha. So this is 4 upon 5 equal to this upon this. Sine alpha gone. This is cos theta plus cos by sine. That is cot alpha sine theta. Tan alpha we got 3. Tan alpha we have 3. So cot alpha will be 1 by 3. We put here. So this is 4 by 5 equal to cos theta plus 1 by 3 into sine theta. Now from here we need to find uh, theta. How will you find theta? See, just multiply by 3. So this is 3 cos theta plus sine theta equal to 12 upon 5. How do you find that? Sorry, that is not possible. This is wrong. This cannot be. Oh, right. Yeah, it can be possible. It can be possible. Yeah, correct. Now, a cos theta plus b sin theta. How do you do this? You just have to divide and multiply by under root a square plus b square. So under root a square plus b square. That is under root 10. So divide and multiply like this. Balance it. So suppose this is your sine beta. Assume. So if this is your sine beta, so this will be sine. Array, this is very bad. We cannot solve it. Don't want to solve this. This is how we can solve, but this is not good data. So let's do one thing. Just pick this angle 59 degree. That is not a standard value. So let's assume this is 60 degree. So cos 60 is half. Here, sin 60 root 3 by 2. So how much it will be? 1.5 and 1.7 by 2. 0.85 approximately. So this is 10, sorry, 5, this much. And this is also approximately 2.4. Very good. Like they are very close. So that's how we can find. If data was good, we could have like, do like apply the trigonometry and we could have find the correct value. But in this case, we cannot find. So that's how we can do. But did you understand the concept of this question?
Yes, sir.
Hmm. Note that. Archit, समझ में आया?
Yes, sir.
I think last concept left in this chapter is velocity of separation, velocity of approach. That we will finish in next class, but we will do a few more questions. Let me know once done.
Yes, sir. Done.
Archit, हो गया?
Yes, sir.
Last question. Let's check this question. This is from Erodo.
सर एयर ड्रैग मतलब कि वो बॉडी के डायरेक्शन में ही लग रहा है ना?
नहीं, ड्रैग ऑपोजिट
अच्छा,
जाएगा ना।
ऑपोजिट 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 ना, ठीक है
सम,
ठीक।
हाँ, रेसिस्टिव एयर जो मतलब फ्रिक्शन क्रिएट करेगा काइंड ऑफ।
So only in the downward direction, right? When the mass
A
is
body
falling
of
down.
mass m is thrown straight up with velocity v naught. The velocity v dash with which the body comes down if the air drag equals kv square. Drag means, suppose if you're going up, air drag will act downward. If you are coming down, air drag will act up like this. Do you understand how to start with?
No, sir.
Okay, wait, see. See, when this block will be thrown upward with some velocity v naught. So initially at time t equal to 0, velocity was v naught, right? It will go up. So it will go up. So mg will act towards down. And because this block is going up, so drag will always oppose the motion. Friction always opposes the relative motion. So this is your air drag, let's say FA, air drag. And that is given as kv squared. It means air drag depends on velocity, speed. Air drag depends on speed. If speed will increase, air drag will increase. If speed will decrease, air drag will decrease. Understood? And air drag will always oppose the motion. So when ball is going up, drag will act downward. So now in this case, you can see that mg and drag both acts downward. So the F net is, net force will be air drag, that is kv square plus mg. Of course, this ball will go up to some height and it will stop because retardation is it is uh, retarding, right, with time. So if you find acceleration, that is kb square plus net force upon m. But acceleration is decreasing. So this can be written as minus dv by dx. Dx means x is the displacement along y-axis. A equal to dv by dt or v dv by dx, right? That's how we write. And why I applied negative sign? Because velocity keeps on decreasing
इंक्रीजिंग,
while going up.
डिक्रीजिंग।
Because huh?
अच्छा सर ऊपर इंक्रीजिंग होगी ना?
नहीं बेटा, if you throw some object,
It
gravity is
decreases.
working downward, air drag is also acting downward, so net force is acting downward. So of course, like that ball will go to some height and will stop somewhere. So velocity तो decrease ही करेगा ना while going up. And the acceleration is dv by dt, rate of change of velocity. So velocity will keep on decreasing. That's why this rate will be negative. Because the rate is how do you find rate? That is final minus initial. Here you have thrown some object. It will go here and stop. Or its velocity will be less as compared to this. So V final will be less, V initial will be more, final minus initial negative. Right, Archit?
यस सर, वो कंफ्यूज हो गया थोड़ा सा।
This is, अब ठीक है, confusion दूर हुआ?
हाँ हाँ।
ये now you just have to integrate this. So this is minus V dV upon. We have to separate the variable, and this is your 1 by m dx. Integrate this, constant mass is constant, so it will come out. Integrate this. Now you can see that when x was 0, means here, velocity was v naught. When x will be some height, it will, uh, any height given? No, no. No height is given. Okay, let's say it will go to height h, final, where its velocity will be 0, right? Now, how do you integrate this? I told you, like, you just have to assume this as some other variable, kv square plus mg equal to t. Differentiate this, k into 2b dv. Archit, you had joined, like, 12th grade integration class yesterday, so you must be understanding this. Shaina, do you understand integration?
Yes, sir.
Okay, very good. So now you can see that VDB we already generated over here. So VDB can be replaced as dt upon 2k, and this thing is t. Because we have changed the variable, so we have to change the limit as well. So when v was v naught, t will be, just put v over here. That is kv naught square plus mg. When v is 0, so t would be, put v is 0. That is mg. So limit will change. So when v was v naught, t will become this. Now, so this t will become kv naught square plus mg, and this will become mg. And this is your 1 by m, and this is your dx. Integration of dx is x, and this is the upper limit, and this is the lower limit. So this 1 by 2k will come out. 1 by 2k will come out. 1 by t, that is ln t mg upon kv naught square plus mg. This is 1 by m into h, upper limit minus lower limit, h minus 0 h. So this is 1 by 2k and ln mg minus ln lower limit, that is kv naught square plus mg, that is h upon m. Now you can simply write this as ln a minus ln b, that is ln of a by b. Ln of a by b. This is the formula of log h upon m. Just take this to right side. Ln mg upon kv naught square. This is your 2hk upon m. Just remove this ln. You can write simply. Arey yaar, this is too long. E raised to, base is e raised to complete thing, 2hk upon m. So from here we can find what we have to find. We have to find um, we have to find velocity v dash with which the body comes down. Acha, when this body will strike the ground, then okay. So for that, first you note it now.
So can you explain the part before the integration?
Again, this thing.
No, that's like no after like. So how did you get kv square plus mg
See here,
equals? Yeah, the bottom point.
see now, variable is v. We have limit v naught and 0. We have changed the variable from v to t. So when you have to change the limit as well. When v was v naught, t will become, you have to put this value v over here, this complete thing. When v will become 0, t will become 0 plus mg. Then put the value in the limit.
Oh, okay.
Okay, first you note it down step by step. I'll again I again have to write this much for the
Done, sir.
downward journey. Done. Huh?
I wrote it.
Yes, sir.
Noted. Complete thing.
Yeah, so I was writing when you were saying it, sir. That way I remember it.
There. Fine. Archit, you also noted?
Yes, sir.
Okay, now from here you can see that. We have to find actually height. So don't do this. This is not needed actually. This is not needed. From here only we can find. So height we have find. Height is m upon 2k and this is ln mg upon kv not square plus mg. This is the height this body will gain. Right. Now see. This is the ground from where it was thrown and it has come till here. This is the height h that it gained. Now it will come back. When it will come back, this was the upward journey and now this will be downward journey. So with what velocity it will strike this ground that we have to find. So downward journey, it has to travel this h height. Hai na? Now in downward journey, because drag is there, air drag is there. So when body will fall, mg will act downward, but in this case, drag will act up. That is kV square. So net force will be mg minus kV square because we know that definitely ball will fall down. So net force is towards down. So net acceleration will be towards down. And this acceleration is can be written as v dB by dx. No negative sign. Mg minus mv square upon. Now you can see that v dV upon mg minus kv square equal to dx upon m. Initially, x height was h at top. Finally, it will become 0 on ground. And when it was at top, velocity was 0. And when it will strike the ground, velocity will be v dash. That's what you have to find. Now, again, assume
So
this
why VdV by dx?
acceleration is, see, acceleration is written as dv by dt, or you can write v as dx by dt.
Oh, okay, got it.
Or you can, no, not like that, like this. So dv by dx into dx by dt. So dx by dt is v and this dv by dx, right?
Yes, sir.
Now you again have to substitute this. Suppose this is p, some other variable. Here minus 2kv dv equal to dp. Put over here, the v dv is, will be gone from here. That is minus dp upon 2k and this is your p. And this is your 1 by out. This is x, upper limit 0, lower limit h.
So what is that in red ink? Mg minus kv square equals.
Sorry?
So what did you write over there? Mg minus kv square equals.
That is p. Now,
So
velocity
what
is,
does P stand for?
sorry,
What does P stand for?
p some variable like t,
Oh,
y, p, some like something like that.
okay.
So put v equal to 0 here, you will get p as mg. And v equal to v dash, you will get mg minus kv dash square. So minus will come out, minus 1 by 2k will come out, ln p. 1 by p is ln p, mg minus kv dash square, mg. This is 1 by m, 0 minus h, that is minus h. This minus and this minus will be gone. And then put this value 1 by, or 1 by 2k, you can take that side. Or you can say, okay, fine, that side. Put here, this is ln mg minus k v dash square and minus ln mg. This 2k will go to that side. 2k upon m and h that we already found here. This thing. Just replace this thing here. M by 2k. From here you can replace m by 2k into ln mg upon k v naught square plus mg. This. You can see here ln a by b. That is mg minus k v dash square upon mg equal to ln mg upon k v naught square plus mg. See, ln gone. Don't
So you
cancel it in each
multiply.
other. Huh?
So you multiplied them.
No, here just put the value of h from that we got from previous case, like in an upward journey,
Oh, okay.
and then that will cancel. So don't cancel ln like this. I did here in exam, just to make you understand. I did this. So this equal to this. So mg minus k v dash square upon mg equal to mg upon k v naught square plus mg. Just cross multiply this. This is a minus b. No, sorry. No. Mg into this. That is mg k v naught square plus mg whole square. This into this. That is minus k square v naught square v dash square and minus mg k v dash square. This is your mg whole square. This and this gone. You have to find v dash. So v dash is here and here. So mg k v naught square equal to bring these two terms to right. That is k square v naught square plus mgk into why it is k square? Okay, that is v dash square. So v dash is square root of mgk v naught square upon k square v naught square plus mgk. This is the answer. Should match, I think. V naught will come v naught by v naught. Okay, v naught. Okay, fine. Let's do this way. Just bring this to denominator v naught square, chi square root. It will be v naught. This will come down. It will be like this upon this. So k cancel. So this is k v naught square upon mg plus mgk by mgk1. Yes, k v naught square by mg plus 1. Correct. Matched. I hope you guys have enjoyed this question.
So it was very long, sir.
It was very long, but did you understand the concept?
Yes,
Yes,
sir.
sir.
That's what matters actually. For advanced, we have to strong our imagination.